Hello everyone and welcome to GeoNodes Challenge Series, where I dig deeper into geometry nodes to show you the potential of this amazing procedural tool that Blender has for modeling and animation. And this holographic map of a planet that you see here is going to help us learn a lot of stuff about geometry nodes. Like I said, this is a mini series. It has 6 parts. A quick brief was shown at the beginning about what each part will treat. We are at part 3. If you haven't saw the other parts, I encourage you to start with the part 1. You will find the link in the top right corner description and in the description of the video. But for now, let's check out what we will see today. As you saw in the demo, we have these tracer lines here that the moment they impact the surface, they do some blue or red animation, and that it's fading and all that good stuff. In order to achieve this kind of an effect, you have to send some data to the shader. So the shader will be aware of what the geometry nodes does. So what you want to send the data about the start point and the data about the end point and the data about the animation that is going on here, so you can fade these points. So things to be mindful of. While I did that, I am bothered by how big these lines are. So let me quickly just decrease this value. Maybe something like this. Okay. This is where we left off in the previous part. All I did was do some color of the frames and some labeling. So we have here the flight path that we created, and we have here the animation for the tracers, the one that you can see here. And like I said, we want to send this animation data to the shader. So what we want is to send this data to the shader of the planet. This part here. So let me quickly do a Control-C, Control-P, plug this node here and select the placeholder material, the green one. And now we have some shader on this planet. So we want to make this shader of the planet aware of what's going on with this animation, to know when a tracer line, actually a flight path, touches the surface and when a tracer line comes close to it. First, I thought that we can do this easily by taking the data from the animation itself, and that would be this node here that makes sure that this animation wraps, and it has different animation data for each and every spline here, each and every tracer, and send that to the shader. The problem with that was that unless you do a crazy subdivision of the surface, giving that this information is stored either on the let me do this, either on the points of the mesh or the corners of the mesh or the mesh itself, you will get a very coarse result unless this mesh is, like I said, crazy subdivided, which is not exactly what you want. So I had to find another approach, but more on that later. Let's think about how to send the data for the start points of the flight path. The way to do that is to capture an attribute on the mesh that we want to play with in the shader, and then we can access that attribute from the shader. I'm going to show you how to capture the attributes, and then we will do at the end a test in the shader. So let's capture the attributes for the start point, and we want to do it on this mesh, like I said, on the mesh of the planet, this mesh. So let's do it here. I'm gonna add an attribute, capture attribute here, and I'm gonna do a frame for it, and I'm gonna give it a blue color that I use for the UVs and stuff like that, so I can easily see what's going on. See, we have green that is for the things that we can change. We have this bluish color for the materials. We have purple for procedural animation. So even at a glance, we can see what's going on. So what data we want to capture? Well, we basically want to capture the we want to capture the proximity of the starting point to let the mesh know that we have a point here in the proximity. So that means we want to use this flight path data from here. And specifically, we want to do it before we turn it into a mesh because we want to access the points from here. So let's do a geometry proximity. This node here. Let's take this data from here. Sorry about coughing. I have a sore throat. And now we will use the distance here. We want to store it as a float on the point domain. So let's do just that. And as you can see, we have this error pointing out. We can switch to points and it still doesn't disappear. Because we basically want to have mesh, but we don't want to have so much geometry like we have here. So let's just take this curve to mesh node. Let's do Shift D, Alt P to remove the frame and plug it here. Now the error disappears. And now we have this mesh. But we still have a problem. Let me hide the inputs that we don't need. Now we are sending all the data about every point in the spline. We just want to select the start point. So how can we do that? Well, let's go and take a separate geometry node. And point is just fine. And we will build a selection. And this selection, we can base it on two things. We can use a curve endpoint selection. That's going to be one way to do that. So we can take the endpoint selection and select the start point with the size of 1 and the end size of 0 and plug it here. That's going to select the first point of each spline. And another way to do that is also to use, like we used before, the spline parameter node that has an index. And then we can do like compare, switch this one to integer, select the index and say the index equals 0. That means the first point. And then we can plug this one here. So let me just put everything here in this frame. So now we have a selection of the points. Let me hide what we don't need. And we turn everything to a mesh. Now we have a proximity working here. So now we have an attribute capture on this geometry. So what we want to do with this one, we want to expose it to the shader. Let me just move it like this. Let's take this one, drag this noodle and plug it to the group output here. And we have an attribute. Then If you don't have the N panel open, just press N and then go to the group, and at the output you'll find your attribute. So what do we want to do with this attribute? Well, we want to play a little bit with the parameter and give it a name. So it's a float, that's okay. It's on the point domain, that's okay. It has an infinite range, that's also okay. And what else we want to do? It's to give it a more descriptive name, because attribute is too generic. So let's say for this one, point of impact, and to keep the names short, I'm going to put the initial point of impact, and I want to know that is the start point. Awesome. But that's something that we as humans can see. Geometry nodes is using this value here. So you have to go here and copy the name or put whatever name you want. This is the name we will use in the material. So remember that one. We did that. And now we want to capture something else. We want to capture the animation, meaning this tracer going around this line. Like I said, we can't do it by capturing this value because we don't have enough geometry. So we will also use proximity for this one. So let's do just that. We will use another proximity, but this time for this we will duplicate this node, duplicate the capture attribute, plug it here. It's also going to be a float point, but the geometry that we care about is going to be this one here, this tracer geometry that we get here. See, is this one here. We want this, and we want the full geometry right now. And we can capture again the distance and plug it here. And now we can expose this value here, plug it here, and give it a name. So this is point of impact, and it's gonna be fade over time for the start point. Awesome. Also infinite the range, point domain, excellent. Control C here, Control V here to press the name. This is very important. If you don't have it here, it's not going to be visible in the material. So once we did that, it's time to do basically the same thing for the endpoints. So let me just do this. I'm gonna just frame it and plug it here and do a Control Shift D to keep the links, put it here, and this is gonna be the start, and this is gonna be the end. Because it's basically the same thing that we are doing here. The only thing that changes is this mask. We don't want the first point, we want the last point. So remember, these splines have 3 points, a middle point that you use to bend the lines, and a start point and an end point. So we can just change this one to 2. So we have the third point, meaning the last. Of course, we can use the end position like we did it before. So now we have these 2 attributes that we want to expose, and we can do the same thing here. We just plug this one here, and then we plug the second one here. And before naming them quickly, so that we will not forget, the geometry on which we doing this is gonna be this one. So we basically put this in series, and we can put the output here. So now everything gets sent to the shader. These attributes for the start point, these attributes for the end point. So now we can rename those. So let's take this value and put it here, but instead of start, let's call it end. And for this one, let's put it here, but instead of start, call it end. Let's copy this value, put it here, copy this value, put it here, and let's save the project. We should be good to go. So basically, it's time to go to the in shader test and see if things are working as expected. So I'm gonna switch this to the shader editor, and we want to look at the green material. This is the material for the planet. And now we can switch to the geometry here, and let's start to play with attributes. Let's do attribute, and we just copy this point of impact start, put the name here, and this factor should be what we need. So let me just plug it here. Control H. As you can see, we already start to see something. I'm not gonna build the shader. I'm just gonna do something to make sure that it's working. So let's plug a coral ramp and play with this one. Don't worry, I'm gonna do a video about the shader just as well. So we can play with these values like this to restrict the range. And as you can see, we have this data working just fine. The more subdivision you have on the mesh, the nicer it's gonna look. So if I'm splitting this window quickly and switch to the geometry node editor, press N, and yeah, let's put this here. This is the subdivision. If we put it at level 0, we get this. If we put it at level 5, for example, we get something a lot smoother. And if we put it at 2, we get this. Okay, control, click, drag, switch the shaders, and we can actually close this window. So this is working. As you can see, all the spline have 1 point selected. Of course, if we have more splines connecting here, of course, they will have this point. And let's basically, we did this. I'm gonna do a shader. No, actually color, mix RGB, plug this one here. And let's just change this to have a color, just so we can visualize things better. As you can see, we have this color. Let's make it lighter. Awesome. If we do it like this and switch this one to add, we can now duplicate this one, look at this and select point of impact and plug it here, duplicate this color ramp, plug this one here, plug the result here, and change this color to something else. And let's see, instead of add, maybe color. Let me check first if it's okay. No, this is not working as expected. Let's take a quick look at the geometry nodes. And Let's see, we have this here. I'm gonna try to fix it live and see if it's working. This is okay. We captured this one here and this one here. It's working here. This is point of impact and this is the other one. And we have this value here. And we have this value here for the name. Things should be okay. Maybe a problem with the mask. Yep, is the problem with the mask. Why? I'm gonna pause the video now. Actually, I don't need to pause it because I figured it out. We have this set to greater than. We actually want it to be equal. So if we switch to equal, it should work. Let me see. Point of impact here and here. Yeah, now it's working. So we can plug this one here. Yeah, now it's working. It was that mistake that I made because I made it greater than, but we actually want to select the 0 point and the second point, the last point with the index 0. So now we have this working nicely and we can play with the values, adjusting the start and end points. So the transfer of attributes is working just fine. We want to see if the other thing that we send it here, the point of fade over time animation is working, meaning this data from here. So let's duplicate this node and let's put this attribute here. And just quickly to make it work, I'm gonna replace this attribute here. And Shift D, take this attribute, Control Z, Control C, Control V, put this one here, put this one here, and see what's happening when we played with the animation. We get something working, as you can see. We get this fading of the animation and starting of the animation. So basically, we can simply reverse this one. And now when we play with the animation, as you can see, something is happening here. Yeah, something like this. It's just a matter of playing with the values now. The important thing is that the setup is working. So if we simply just remove this, we are looking at the point of impact fade animation over time for the start points. And if we play with the animation, we can see how the data is transferred to the shader based on the movement of the points of the tracers. and the same one goes for this other one, and we get these values that look different because of this shader, this hologram. So basically it's working. This is what we care at this point. We will be looking in a future video, in the last one, on how to build the shader that we show in the demo. For this video, it's okay. I think we can stop here. Make sure to watch the next one. We will be playing a little bit with particle effects. We will build it, of course, in the geometry nodes, and we will add the ones that you saw in the demo inside of it. It's very interesting how you can create a particle cloud that has a spherical shape and a random distribution. This is what we will be doing. And we also are going to add an animation that will make all these points flow to inside and to the outside, something like this. It's gonna go like this and back. So that's gonna give you the chance to learn how to do something other than this holographic effect. You can do a bunch of other cool animation with that technique. So make sure to watch that video. So until the next video, thank you very much for watching. It was a real joy for me to make this video. I hope you found the information useful. If you have questions, things that you didn't understand, make sure to put a comment in the comment section and I will answer it. Until the next video, happy blending and